On the 22nd, what we're going to be doing is looking at the densities of zebra mussels and quagga mussels along a number of transects. Eventually, the idea is to compare the densities between the two.
They are native to what they call the Ponto-Caspian region. In the 1980s, people first started noticing in the Great Lakes that we were getting some of these invasive mussels. They could also travel on people's recreational vessels to places like the Finger Lakes. Zebra mussels tend to attach to plants that you might see in the lake or to rocky surfaces, and quagga mussels prefer soft sediment. And then we also have recently been trying to figure out if they have played a role in the development of some of the cyanobacterial blooms that have been increasing recently as well. All summer, you have everything that's being produced in the lake sort of sinking to the bottom as it dies, and nutrients accumulate there. The zebra and quagga mussels can take algae in and eat them, that's their food, and then they're gonna basically excrete all of that, and they can increase the nutrients there. But there's other complicating factors as well. So the quagga mussels that can go deeper onto these soft sediments, they are present and releasing nutrients right near the bottom, and most things can't access that, but some of these big cyanobacteria, they are able to be at the surface in the day, and then at night they can go down into that deep water. That may be giving these really big colonial cyanobacteria an advantage. If at night when they're not photosynthesizing, they basically go and get a midnight snack down at the bottom of the lake by taking up those nutrients that the quagga mussels have released down at the bottom. That's one possible way. Carolyn Underwood is a student, a senior at Syracuse University, and she's doing a project related to Owasco Lake. And we set up a simple experiment to test this idea. Do the mussels themselves, the quagga mussels that bury in the sediments, would just the presence of the mussels interacting with the sediments release more nutrients? Because that could increase the cyanobacteria. And then we have controls that you're looking at now that don't have any mussels in them. And then we have two treatments that have mussels. One where there's screening very near the top that prevent the mussels from going more than 2 centimeters into the sediment. And then one where they can access the whole sediments. And every day Carolyn comes in and she takes a nutrient sample to see how much nitrogen and phosphorus are being released from the sediment. Sediment without mussels, so that's our control. Sediment with mussels that can naturally interact with the sediment, and then sediment with mussels that are constrained to just the top treatment. We're really just investigating if they're affecting that sediment-water interface. Can we attribute any given bloom to one of these factors? Right now, no, I don't think so. We know all the things that might be contributing, but we really can't say like this algal bloom was definitely due to this factor. We can't answer that question yet.